All right. So um, out of all these measures which will help us to decide or say something or to characterize data, the very first one will be the measure of central tendency, or the measure of the center, which will basically, in brief or in short, it will give us the idea of where the central values of the data are, or what are the expected possible central values of the data. Right? So there are different central um, measures of central tendency, measures of central tendency, and there. I mean, the important ones are like for mean, median, mode, and geometric mean. And there are also, I mean, very classified one like harmonic mean and other kind of things. These are the next topics which will also give us some idea about the measures, okay, about the data. So, for example, this variation will give us how much variation is in data. I mean, it's a difference from minimum to maximum. So, this lecture is about central tendency. Okay, measure of central tendency, a measure of center of the thing. This is another, I mean, a topic shape, which gives idea about. So it's also a type of measure which says gives us different information about the data. Okay, so this is today's lecture. Central tendency, the yellow one. This one. Screen is it still visible? Because I just popped it to the screen mode. Okay, so this is today's lecture.
Excuse me, sir. Sir, I can't hear you properly.
Anyone else have the same problem?
I don't know. No, it's audible.
Is it clearly audible or? Let me check. I'm using is it audible now?
Yes, sir, it's audible.
It's better now, or?
Yes, sir. It's
okay.
better.
Okay, so this is today's lecture. Central tendency in 4 different types of the central tendencies. Measure of central tendencies basically. In brief, so mean is computed like dealing with the values and the numbers. So it encounters or considers all the values, and geometric mean is also encounters while computing geometric mean. It encounters or it uses all the values. Median is just locating the middle number, middle value. So it's like sorting out things and then just hunting or locating where's the middle value. And mode is just the most frequently occurring value. So this is just a, I mean, brief overview, but we will see step by step about all these 4 types of the central tendencies. One thing you need to remember, so Zoom session allows us to, let's say, continue session for 40 minutes, and after 40 minutes, if the session is discontinued, you need to rejoin the session. Okay. Okay, so this is formula for computing mean. I think it's a bit so first there should be some example and then the theoretical part of the formula. It helps us to digest easily but well. So this is formula for the any sample. When the sample is given and when the complete population is given, then the mean, the formula for mean is this one. There is no difference between computations. So basically we sum all the values and divide by the total size of the sample or size of the population. But customary, I mean, the literature, or we use different notations for sample mean and the population means. So in effect, they are not, I mean, different from each other, but sample mean just uses all the sample values, and population means uses all the population values, so complete values. Okay, so these are formulas for the mean. This is just a property of the mean. I mean, this is most frequently used measure for the tendency of the center, or central tendency. But there is a drawback, apparent drawback of this central mean is when we have a few very large values or few very small values, then this type of, measure of center is severely affected, or it can give us some wrong information. So as an example, so just look at this. We have some random 5 values, and the 5 readings are values. So the readings are 1, 3, 5, 7, and 9. So if you compute the mean of these one, and that will be by let's say adding all these numbers and dividing by 5, you shall get 5 is a mean. But for example, think about another data set where the values are 1, 3, 5, 7, and instead of 9, we have this one value 14, which is certainly the larger one. So if you compute the mean of this data set, so that will be 6, and that is because of this 14. Now think about if this 14 is somehow larger than 14 even. I mean, if it's 20 or 30, so this mean will be greater and greater. So this outlier, one greater value, one extreme value, or similarly one smallest value, or few smallest value in a very large data set can affect this mean. So this is just a point of where one should be conscious while using mean or computing mean. While using mean is more, effective. So now let's see some example. We have this example data set of 13 persons weekly salary or wages in the first half of the summer. Jeevan.
Sir, the window is not visible.
To everyone?
Yes, the PPT नजर आ रही है.
नहीं.
Now you can see the example number 1.
No, sir.
Oh my God, yes. Oh. Okay. Share, and this one share. Now you must be, seeing this example number 1.
Yes, sir.
Yes, sir.
Okay. So example number 1 is the weekly salary of 13 persons working in some first half of the summer. Look at this data, 300, 303 in dollars. So mean of this data set will be, how will you compute the mean? You should remember the formula. So this is complete population, or let's say sample. So this is equal to x1 plus x2 plus plus x3 plus x4 plus x13. So we know that there are total 13 values divided by n. The sample size is 13. If you sum all of these values and divide by 13, it is equal to 6290 divided by 13, and that gives you this value 483.85. So this is mean of this data, the normal mean of this data. Okay. Sometimes we use the word, what is the average salary of the persons working in the first half of the summer, let's say. So this is that average data for all these persons. Okay. Similarly, come to the next example. So now we have a data set of 10 persons whose salary is given I've chosen this example because it becomes interesting when we try to compute the other types of the Myers of center. Okay, so this is another data set. Mean will be like, do you recognize this notation? Summation
Yes.
xi means sum of all these numbers till the end. Let's say x10. Sometimes we do not just exclusively mention this end number because data is in front of us, but it's better to, I mean, highlight this. It starts from 1 to 10. Summation divided by n, which is of course 10. So sum of these numbers is this one divided by 10, and this is your mean of this data set. So if 10% are getting these amounts of salary, so the average salary of a person is $474. Okay. This is the interpretation from these two examples. So this is what we just tried to say. Employees who worked in the first half of the summer, their mean salary is 483, and the worked in the second half, because this is second half, and their mean salary is 474. So this is how we interpret, or we try to, I mean, to know what this mean gives us, or the information of the gives us. Okay, so we discussed outliers already. So we can we have a remedy. I mean, we can deal with these outliers if there are, for example, some outliers in the data. So they can affect. We just saw in the previous example, not example exactly example, but I mean, we saw in this one. Is this visible to you? The mean, arithmetic mean now?
Yes, sir.
Yes,
Yeah.
sir.
Okay, cool. So just to be, I mean, familiar, I'm trying to be familiar with Zoom, so we can share multiple windows. Right? Okay, so so just have a look how we can deal with these outliers. So example is a given. For example, 10 values are given. These are the scores, marks obtained by students in economics course or economic subject. Let's say one student got very, I mean, 0, and the highest marks are, let's say, 80. So if you compute just the usual mean, the normal mean, it will be like 0 plus all these divided by 10, and this is your usual mean, 61, the average of the students. But the trimmed mean, the concept which, I mean, remedies our these outliers, or the smallest and largest value, is you just try to trim the extreme values, be on the both sides, on the smaller side and also on the large side, and the same amount of the data values is trimmed. Right? So one value is trimmed on left of the, our minimum value is, I mean, trimmed, this 0, and also this one is trimmed. So these 8 values are used for computing this trimmed mean. Okay, so if you just sum these numbers, and now this somehow represents proper mean of these students. Okay. Otherwise this 0 would have dropped down the average of the students, or the mean of the students, to 61. Okay, and think about, for example, if these are the scores of 10 subjects I have passed, I have been cleared, so this 0 would have dropped my percentage, my average score, to 61. And if, for example, I do not have this 0, no matter if I do not have this 80 also, so out of these 8 subjects, my average score is 67. So the same numbers, same data can represent a different situation. For example, the scores of my 8 or 10 subjects. So this looks
Sir?
better, and this is given.
सर ये यूजुअल और ट्रिम्ड में फिर फर्क क्या हुआ सिर्फ जीरो का
So trimmed is you trim the outliers. Where we trim outliers, and outliers are extreme values
First and last number.
for the minimum and the maximum. Minimum and maximum both are the extreme values. So minimum is 0.
क्यों जरूरत पड़ेगी अलग-अलग यूज करने की? किस सिचुएशन में लगेगा कौन सा?
When we have very few extreme values. So overall data is between 85 to 78 or 80, but this 0 is too far. So that's why we call this value as extreme value. Now, in order to trim this, or in order to avoid this trim, we use a trimming technique, and the trimming technique is, if you want to ignore this number, one value, इतने ही values आप right hand side या maximum side पे भी आप ignore करेंगे, ठीक है? So ये 0 यहाँ से ignore, 80 यहाँ से ignore. So mean of these numbers will give us somehow the proper representation or proper center of these numbers. ठीक है? Did I answer your question?
Yes, sir.
Okay, so this is difference. This is a normal mean, which we computed in the previous example. And this is trimmed mean where some extreme values are available. So to avoid these extreme values, we use trimmed data, and hence we compute the mean, and that mean is called trimmed. So you can notice that we have divided with 8, and we have also used the 8 values. 0 and 80 are not used in this one. Okay, so this is concept of the trimmed mean. So another example on this trimmed mean. Now this example presents the marks of the 20 students in a midterm exam in accounting, for example, out of 30 or 40 or 50, let's say. So this is a data set. Just have a very keen look. We have to respond these 5 questions for this given data. The very first one is, do any of these marks look like outliers? So any student have very extreme marks?
So 4 and 28 and 2 and 27.
All right, so I would just classify 2 and 4 are the outliers, or the extreme values. 28, 27 are the maximum values, but 26 is very close to 27. 25 is even close to 27. 24 is there. So these are not outliers. 2 and 4 are outliers. So I would just like to say 2 and 4, but in order to let's say have the proper mean, I mean the more sensible mean, we will use trimming, and that will trim 2 and 4.
Excuse me, sir.
Jiva.
Sir, can you please explain outliners again?
Okay. So outliers are, let me write it. Outliers are extreme values in data. And now what do you think about extreme values? Minimum or maximum, which are basically distant from most values. Now you understand this one, minimum or maximum values which are distant, which are away from the most values, the rest of all the values. Now,
yes,
just think about this definition, and which values do you think are outliers, are the extreme values? So 2, because the rest of the values, and 4, the rest of the values are very far from 2 and 4. So the distance between 4 and 15 is kind of 11. 18 is the maximum value, but 27 is there. I mean, there is not much distance. 26 is there. So we have this trend in the data 27, 26, 24, and then difference of 3, 21 and 20 and 19 and kind of thing. But these are clearly outliers, or the extreme values, because all the other values are at too much distance from these two values. Does it make sense now, the outliers?
एक्सट्रीम वैल्यूज का मतलब ये नहीं हुआ अगर जो डेटा में जो सबसे स्मॉल है और फिर लार्ज है मतलब 2 and 28 ये मतलब नहीं है
No, not the smallest one or the largest one. I mean, they should look odd in the data set. This is an intuitive feeling about hunting, or let's say recognizing outliers. So proper उसकी definition ये है कि they are extreme values, और extreme word हम numbers में या most minimum और most maximum के लिए use करते हैं, ठीक है. So वो extreme values जिनसे बाकी सारे values ज्यादा दूर हों.
तो सर ये 2 और 4 से बाकी सब वैल्यूज बहुत बड़ी हैं इस वजह से हमने इनको लिया.
Exactly. So this is the reason. So 2 and 4, the rest of values are very far from these values. Let me give you another example. So then it maybe it makes sense. So this is result of intermediate students in Karachi board. So what was the example? Okay. Number of students and percentage, ठीक है, but greater than percentage. 99, 95, not greater than, but well equal to, but do not make it more complicated. So 99, 95, 90, 80, and one last maybe 70. So now you can think there will be very few numbers. Let's say 3 students got 99%, and here will be 3,500. 80 maybe 1,500. 90% there will be a good number like 750, and let's say 50 number is there. So what do you think? What are the outliers? These three are the outliers because they have the most percentage, and yeah, they are not very coherent with the rest of the data values. Even the 50 is outlier. So it again depends upon the situation. How many outliers do you want to trim or avoid? ठीक है.
Sir, so इस केस में outliers सिर्फ 3 होगा ना?
जी 3 होगा. Yep. देखिए आउटलायर्स का मतलब सिर्फ मीन में यूज नहीं होता, ठीक है. जब भी डेटा आती है तो उस वक्त आउटलायर्स मतलब डिफरेंट पर्पस के लिए यूज हो रहे होते हैं. अब जैसे इस डेटा को देख के अगर कोई पूछे तो ज्यादा स्टूडेंट्स ने कितने परसेंटेज मार्क्स लिए, तो एक आम सा या नेव सा रिप्लाई ये होगा कि मोस्टली स्टूडेंट 70% दिए, and that is because of you just considered this value, and this is another measure. अभी हम मीन डिस्कस कर लें तो ये मोड का एग्जांपल हो जाएगा. So let's go step by step, but just think आउटलायर्स वो वैल्यूज होती हैं जो डेटा के साथ थोड़ी सी आर्ट उनका वहाँ होना लगता है, ठीक है. उनका जो वहाँ मौजूद होना है, it doesn't look really nice बाकी डेटा वैल्यूज के साथ उनका. या तो वो बहुत छोटे होंगे या वो बहुत बड़े होंगे। ठीक है, अगर आप इसको एज अ मेन वेरिएबल देखें तो दिस 99% इज लुक seems like an outlier। केस में तो बहुत थोड़े मतलब लोग हैं और बाकी इन तीनों में मोस्ट ऑफ द स्टूडेंट्स यहाँ पर हैं। ठीक है, सो दिस विल बी अवर, जैसे अगर रिपोर्ट करना हो कि मोस्टली स्टूडेंट्स हमारे इसमें आए हैं इस क्लास में 70 to 90% में। ठीक है, और इससे आगे बहुत कम है या क्या। ठीक, I hope it made some sense, no? It cleared things. Did it? Any question is still welcome, no?
सर 3500 इज प्रीटी फार ऑल्सो के उसके अंदर 1500 और 3500 के अंदर 2000 का फर्क है, तो
Yeah, this
3500 को
is
हम
very nice. I mean, pointed out. This is also a problem when we have a very small data sets. So वहाँ पर 3500 is also outlier. True, I agree. Completely agree. So distance between the literal distance between these two. Now these kind of things will not happen when we have 1000 data types. ठीक है, अगर सिंपली अगर आप रियल डेटा शीट लेके उसमें अगर 50 वैसे 70 to 90 30 डेटा क्लासेस तो होंगी ना। 70% कितने स्टूडेंट, 71% कितने, 72% कितने, 73% कितने, एंड सो ऑन। ठीक है, तो yeah, I agree in principle this is also outlier। extreme value looks like extreme value। ठीक है, but okay, so I think there is some fill in the gap about the outlier. So when you confront the examples of the data sets, you will get to know more about the outliers. Do you agree?
Yes, sir.
Okay, can we move further?
Sure, sir.
Okay, so this is example. We have outliers, and the response is, or the first question is yes, we have two outliers, 2 and 4. Next was compute the mean. Compute usual mean. So usual mean is summing all these numbers and divided by the number of sample size. So these are 20 values. If you just count 1, 2, 3, 4, 5, and these are more 5 times 2 is 20. So sum of all these values divided by 20 is 19.25. This is the normal mean of the data. Okay, and we also call it arithmetic mean or usual mean. So next was compute 5% trimmed mean of the marks. Now this is important, 5%, and how do we decide 5%? So total data set size of the set data set as sample is 20, and 5% of 20 is just 1. Because 10% of 20 is very clearly, I mean, it's 2, so 5% is just 1, and we have to trim 5% on the each side. So before trimming, we basically have to rearrange this data set into ascending order. So like 2, 4, 15, but if you just look at this data, it is already arranged. So you go first this one, and then this one, 2, 4, 15, 15, 16, 16, 16, 17, 19, 20. So these two are the smallest values, and this is the largest value. So trimming 5% means trimming one value on the minimum side and one value on the maximum side. So we start from.
तो सर आप अभी बोले थे ना 2 और 4 लेंगे, फिर वो 2 और 20 क्यों ले रहे हैं?
Can someone answer this question? Someone help me to answer this question.
सर इस वजह से ले रहे हैं क्योंकि 5% ऑफ 20 जो होता है वो 1 होता है, तो हमें एक आउटलायर रिमूव करना है। तो अगर 10% ऑफ 20 होता तो हम 2 और 4 को दोनों को रिमूव करते। तो अभी 5% ऑफ 20 पूछा हुआ है।
Exactly. So 5% on each side, minimum 2, and just to make it homogeneous, the largest side, the maximum side, वहाँ पर भी हम 28 trim कर रहे हैं. So in between we will be left with 18 values. That's why you can see we have divided with 18. So sum of all these 18 numbers divided by 18 is like this one. So this is not considered. This is not considered. All these are summed and then divided by 18. So this gives us a 5% trimmed mean of the marks.
तो सर ये हमेशा अंडरस्टूड होगा कि अगर हमें एक सर्टेन परसेंटेज दी हुई है तो अगर उसमें फॉर एग्जांपल अभी तो 1 आया है, अगर जब भी 1 आएगा तो हम एक दोनों एक्सट्रीम वैल्यूज लेंगे,
Exactly.
यानी
Yeah.
मैक्सिमम और
Yeah. While computing mean, आप दोनों तरफ से एक एक या जितनी परसेंटेज होगी वो आप ट्रिम करेंगे. हाइपोथेटिकली जस्ट आप अज्यूम करें कि आपके पास 50 का डेटा सेट है, ठीक है, और आपको कहा गया है कि 5% ट्रिम करें. तो 5% ऑफ 50 विल बी 2.5. अब 2.5 तो डेटा आप ट्रिम नहीं कर सकते ना, डेटा वैल्यूज या 2 कर सकते हैं या 3 कर सकते हैं. सो यू विल जस्ट यूज योर डिसीजन के यू आर ट्रिमिंग 2 वैल्यूज. तो आप 2 मिनिमम ट्रिम करेंगे और 2 मैक्सिमम. दिस इज 5% ऑफ अ डेटा सेट ऑफ साइज 50. ठीक है, दोनों साइड्स पर दो वैल्यूज, इट मेक्स 5%. This will be more clear if you just look at this part D, which says compute 10% trimmed mean of the marks. Now total number of marks is 20. 10% of 20 is 2, and on each side, so 10% outliers on each side means 2 on the minimum side, 2 on the maximum side. So we will just use these values to compute the mean, the normal mean, and we will divide with 16. This is our 10% trimmed mean. Is it clear now?
Yes, sir.
सर
Yeah, I'm here to listen your question. They're well appreciated. You have any question? Fariha, maybe you were asking something.
No, sir.
Okay, yeah, so let's move. Now we have this part E. I think I leave it for you. So you just decide which mean is the better out of this A, not A, but B, C, and D. So just look at this data and which mean is the best one. I just summarize the things. So this is usual mean 5%, and this one, yeah, just write in your own words, or just have your own opinion, and it's completely okay, normal that everyone have a different opinion, or some opinions are coincident with others. So yeah, does it make sense, right?
Yes, sir.
Okay, so this was arithmetic mean. We did examples when we have the normal data, raw data, all frequencies, and let me share this one. Okay, so now another problem of finding mean is, another type of data, or if data is, let's say, given in the group format, or group data is given. Only the frequencies are given, but not the every let's say literal data is given, every value is given. So in that case, we compute mean in this way, where you sum midpoint of the class, or the frequency, or the class, multiply with that frequency, midpoint of the class, multiply with that frequency, and then divide by the total sample size. Now, this seems maybe confusing. So just have a look at example first, and then it will try to explain. Now, this is type of the grouped data. Just have a keen look. I mean, a very nice look. Try to understand this. So 2660 number of students have a score in aptitude test or admission test, which is between 0 and 25. Now, there can be many possibilities. 0 score कितनों का है, 1 score कितनों का है, 2 score कितनों का है, 3 score कितनों का है, 4 score कितनों का है, and so on. This is called raw data. 0 score कितनों का है, 1 score कितने, 2 कितने, 3 कितने, 4 कितने, and so on. ठीक है? But this is called a group data, or data and given in a frequency distributions, because this number is just a frequency of the students who have a score between 0 and 25. This number of students have a score between 25 to 55. Sorry, 50. So this is just typo. ठीक है? And this number of students have data between 50 to 75. Now, there is again, we can have many possibilities. 51 score kitno ka hai, 52 kitno ka hai, 53 kitno ka hai, 54 kitno ka hai, and so on. So sum of all those students having a score between 50 and 75 is 971. And this is the sum of all those students whose score is between 75 till 100. Too many typos. ठीक है? So this is a group data. How we can find mean of the this data? So mean score of the students.
Sir, we will first calculate the midpoint.
So midpoint of these classes are these groups, multiply
Yes,
with
sir.
this number. So this midpoint is just, I mean, it's like we assume that all these, this is assumption, remember, we assume that, so midpoint of this is 12.5. So we assume that all these students have a score 12.5. So we multiply this 12.5 with this one, plus again we take a midpoint of this class, which will be 37.5, I guess. So we multiply 37.5 with this one. This means we assume that all these students have 37.5 marks.
Sir, इसका
Now,
answer 40.
40 होगा.
जी sir.
75 divided by 2 is like 37. Okay, जो भी हो. So we multiply this one. ठीक है? So this is just assumption because we do not know the exact number of students who have 25 marks, who have 26 marks, who have 49 marks, who have 40 marks, who have 35 marks. We just assume all these students have the marks which is the midpoint of this class. So this is how we just compute mean. Okay, so now this formula is like, this is frequency, the number of students or number of persons in that class. This is the midpoint of that particular class. So M1 F1 plus M2 F2 plus M3 F3 plus M4 F4 divided by N. N is the total sample size. So for this case, N is sum of all these numbers.
5812.
What is the number?
5812.
Oh, okay, that was very quick. 5812.
Yes, sir.
Okay, cool. So this is N and
सर midpoint निकालने का कोई specific formula नहीं है?
yeah, there is
करेंगे?
yeah. So MJ is 0 plus 25 divided by 2. This is midpoint. You just add the starting and the end point. Take the average of the starting and end point. and then
Okay, sir.
25.5 divided by 2, this is 37.5, and 50 plus 75 divided by 2, this is like, I'm hanged. Can you help me? It's a 62 point.
62.5.
Okay, cool.
Sir, these are midpoints.
G, these are the midpoints, MJ. Midpoints of class. Okay. I don't know why I'm rubbing this example, but there is a well explanation of another example जहाँ पर mid classes भी है, उसका structure भी है कि आप mean frequency distribution का या group data का कैसे compute करते हैं. Let me finish this example. So 75 plus 100 divided by this, this is 87.5. Cool. Thank you. So these are the midpoints. We multiply these with this, and yeah. I leave this. There is another example because it will cost me more time to do more computations. So yeah, I need your favor. So we will do this next example, and you can do this in the end. So how to compute? These are the 5 steps. And how to compute the mean of the group data or the frequency distribution. Okay, you need to remember what we are, aiming to compute. Okay, our frequency distribution. So very first step is the important. It almost does all the things clear. So just make a table, 4 columns. 2 columns will be given, class and frequency. This third column will be the mid, and the fourth column will be multiplying that midpoint with the corresponding frequency. Okay, mj times j, and then summing all these will be very much easy. Okay, so this first step is just wholly solely, represent all the computation. Leave the rest of the steps for you, but they are just what we will be doing in the example. Okay? This one and this one. Okay, so yeah, of course we will be summing all these frequencies in order to get n, and then we will divide sum of all these with the n. So this is what it's written in this step 2, 3, 4, and kind of 5. So yeah, you would like to see example. So this is the example. The example is visible. Miles run by the persons.
Yes, sir.
All right, so this is a frequency distribution table or the data given in classes, and these are the frequency, the number of persons who just run these miles. Okay, so data makes sense. We have to find mean. Very, the if you just go to the steps, we have to make 4 columns. So this is the first column, second, third, and fourth. M underscore J. Okay. So third column is finding midpoint and then multiplying that midpoint with frequency. So remember, these 2 columns are given. Midpoint of this class is average of these 2 numbers. Someone's mic is maybe distorting. Can you just please? Thank you. So average of these 2 is 5.5 and 10.5. 16 divided by 2 is like 18. 18 is the midpoint. 13 is midpoint of these 2. 18 is midpoint of these 2. And if you just want to give it.
Last column mean का है ना? Arithmetic mean.
This one?
Yes, sir.
No, it's just a multiplication of frequencies with the midpoints.
Okay, sir.
So fj multiplied with mj. So this is just like 1 cross 8 is equal to, and 2 cross 13 is equal to, or in the very last one, 2 multiplied with 38 is equal to 76. 3 multiplied with 33 is equal to this one. 4 multiplied with 28 is 112. Okay, let me finish this. So 5 times 23 is 115. 3 times 18 is 18. So this is just a multiplication of corresponding frequency and the midpoint. And midpoints are, I hope, all are correct. So sum of all these multiplications is 490. Now the mean is, which is this x bar, is equal to sum of fj times mj, which is already computed here, divided by n, total number of occurrences, or the sum of all frequencies. So this is 490. Sum of all these is 20, and this is 49 divided by 2 is 24. So this is mean, or arithmetic mean of the grouped data, or the frequency distribution given in this table. Now, how will you read this, or how will you interpret this? On average, 24. On average, every person just run 24 miles. ठीक है? So on average, person run like a 24.5 miles. So yeah, and one thing you can also note that most persons who run between 20.5 to 25.5 are in this class, and there are 5. Any question? Is it clear how we compute? So let me recall this. We are given this one. We need to compute 2 things: midpoint of the class and midpoint multiplied by the frequencies. So midpoint and then midpoint multiplied by the respective frequency. We sum all these and then we divide this sum by the total number of frequency. That give us the arithmetic mean. Okay, we have another example. I hope it is visible. I just tried to zoom full screen.
Yes, sir.
Okay, so this is how truly universities compute GPA, CGPA or GPA. I think you already, maybe few of you already know. Okay, semester का पूरा GPA कैसे compute किया जाता है. For example, 4 courses are passed, and these are the points in every course, and these are the credit hours of these 4 courses. So 3 credit hours for this, 3 for this, 4 for this, and 2 for this. Now the GPA of this semester is just a weighted, what to say? It's just a क्या कहेंगे उसको? The mean of the group data, mean of the frequency distribution, where your credit hours are just thought or considered as a frequency, or as a let's say basis of the group. So for every credit hour you have these points. So for 1 credit hour you have 4, for another you have 4 points, for another credit hour you have 4 points, for another credit hour you have 2 points, for another credit hour student have 2 points, but for the 6th credit hour 2 points, and then next 4 credit hours 1 2 3 4 student have 3 points, and that's why they are multiplied and then summed all of these and divided by all these frequencies. So this is basically done like the same way. You add 2 columns mj, and then fj times mj. So mj is, well, there is no mj, so this is the only one fixed class. The midpoint is itself 3, 3, 4 and 2. So multiply 3 times 4, 3 times 2, 4 times 3 and 2 times 1. And then you sum all these and divide it with all these frequencies, 9, 10, 11 and 15. No, sorry, 12. 6, 4, 12. Yeah, it's 12. So this is GPA of the average, having these sort of the results in 4 different courses. So if you add more courses, you will have to divide it like more credit hours, and yeah. Is it clear? Is it?
Yes, sir.
Any question? What did we learn? I mean, in these examples, what we were trying to compute or find?
Sir, can you repeat the question?
What we were trying to compute in these examples?
Sir, average
or mean of grouped data. Okay. So we can face two. जी पूछ.
सर ये ग्रुप डेटा के अंदर हम वो ट्रिम्ड वाला स्टेप आता है,
आप यूज कर सकते हैं. That will be well bit advanced, right? So अगर डेटा क्लासेस में जब गिवन होती है ना, now listen carefully. This is, I'm just telling you my experience. Everyone, this is an important question, and maybe it's just out of scope at the same time. So when you have data in classes, in groups, so that is somehow processed data. That's not the raw data. ठीक है, जैसे इस एग्जांपल में थी, this is like a processed data. अगर raw data है तो हर परसेंटेज के अगेंस्ट नंबर ऑफ स्टूडेंट होता. ठीक है, फिर उसमें ये हो सकता था रॉ डेटा में कि 100% स्कोर किसका है, कितनों का है, वेरी फ्यू. ठीक है, उसमें जीरो भी बहुत फ्यू का होता. आई मीन अगर इफ यू जस्ट इग्नोर द एब्सेंट्स वन. डू यू एग्री, आर यू विथ मी?
यस सर.
तो वो रॉ डेटा में ये आउटलायर्स का कॉन्सेप्ट, इट मेक्स मोर सेंस. इट्स मोर, आई मीन, विजिबल, मोर लाइक eye catching कि आप उनको, they need attention, they need some care. But in groups, like if that same raw data is being grouped, our frequency distribution table में हमने इस तरह represent किए. Now we have 2 classes, oh, sorry, 4 classes, 0 to 25, 0 to, these classes even doesn't make. I mean, the meaningful classes for this real sort of data will be 0 to 60, the fail students, 60 to 75, the C grades, 75 to 85, let's say B grade, 85 to 99, the A grades, for example. Okay, so these groupings will make sense. Now, would you like to, I mean, even think कि इसमें outliers होंगे? क्या outliers आप करेंगे? Failures निकाल देंगे or the top one? ठीक है. So outliers are not that important for group data, but well, अगर आपने छोटे-छोटे groups में या कहीं से primary data या raw data का option नहीं है, I mean, we have just got received data in the groups and they are in a very tiny small groups, तो फिर वहाँ पर मुमकिन है हमें ज़रूरत पड़ जाए. कोई immediate example मेरे जहन में भी नहीं आ रहा कि जो मैं आपको दूं जिस ग्रुप डेटा का, कि जहाँ पर आप क्लासेस भी ट्रिम करें मीन लेने के लिए. तो उसमें भी यही होगा कि आप जस्ट ये इग्नोर कर देंगे क्लास कंप्लीट, ठीक है। और अगर ये दोनों क्लासेस फॉर एग्जांपल इग्नोर कर दिए तो आपकी जो टोटल फ्रीक्वेंसी होगी वो 100 नहीं होगी बल्कि 50 होगी। सॉरी, फ्रीक्वेंसी इन दोनों का सम होगी, इन दोनों का सम, जिससे आप डिवाइड करेंगे, ठीक है।
ठीक है सर।
Was it helpful to others also? This was very, I mean, good question. If you are really thinking to do something with data or planning to, I mean, okay. Okay. So this was about mean of the raw data or unique data, classes, non-classes data, and then group data or the classes data. Next measure of the center is median. Median, ठीक है। This is important for certain data. Of course, I mean every type of measure gives. This is very strong claim. I mean every type of measure gives different information. They do not just give the central value or where the central value will be. I mean because उनकी जो एप्लीकेबिलिटी की डोमेन है या जो जिन मतलब डेटास पर मीडियन अप्लाई होता है, जिन पर मीन होता है, वो डिफरेंट होती हैं। तो इसीलिए उनका जो इंफॉर्मेशन देने का अब जो तरीका है मीन का और मीडियन का वो डिफरेंट होता है, ठीक है। वेल दिस इज assumed to be more powerful as compared to the mean, and powerful in a mean in terms of, let's say, it is not affected by the extreme values, the larger or the smallest values. So it is resistance. It is also called resistant measure of the center, is also called resistant measure of center, ठीक है। Because it is resistant to the extreme value. No matter आपके पास extreme value हो, median जो आपको predict करके या बताएगा number that will be more sensible, more meaningful as compared to the mean. Now remember this example in mean. तो mean यहाँ पर क्या थी? Just recall. In this case, mean was 5, and in this case, what was the mean?
6.
It was 6. So mean changed just because of this one outlier or one very large or extreme value. ठीक, लेकिन मीडियन पे कोई फर्क नहीं पड़ा. This is the median, this is the median in this data set and in this data set. तो ये कंप्यूट कैसे की जाती है? मीडियन होती क्या है? Well, this is very simple. You just perform 2 steps. The one is write in ascending order and then find the middle value. That's it. Now there can be 2 situations. If the total number of values are odd, then the median is perfectly middle number. But if total number of values small n are large n, small n is the sample size, total number of values in sample, capital N is the total number of values in a population. The median अगर even है तो median is the average of 2 middle numbers. For even numbers we will have 2 middle numbers. For example 10. So there is no middle number. 4 इस तरफ 4 इस तरफ, 2 आपके मिड में, बीच में. फिर उन दोनों का एवरेज मीडियन होता है. अगर नो टोटल वैल्यूज हैं, 4 इस तरफ 4 इस तरफ, the fifth value is the middle one. So how will you locate this fifth value? So if n is odd, median is n plus 1 divided by 2th position. आपकी इसकी पोजीशन ये होती है, ठीक है, इस केस में. जब odd हो तो n plus 1/2 देखें अगर as example अगर n is 9 this means 9 plus 1 divided by 2 so fifth value is the median it makes sense है अगर even है तो आपका मीड वाले जो दो होंगे उनका so this is median I don't know if you would like to have some example
सर एक इवन की एग्जांपल करके दिखा दो इवन
sure.
नंबर
Okay, so maybe go back to this example let me copy some example from somewhere median. By the way, I got a message from this Zoom that they have extended our session timings from 40 minutes to kind of unlimited. Maybe I don't know. Maybe it was only for this one session. या आगे भी होगा मेरे लिए. So I just loved it. And they asked me whether you loved it or it's okay. So I loved it. Okay, median.
सर जैसे n जो है वो 10 के इक्वल है
जी
तो हम मिडिल टू नंबर्स 4 5 लेंगे या 5 6 लेंगे
5 6 of course middle आपके 5 और 6 ही होंगे ना because 4 on the one side 4 on the other side
थैंक यू सर
and that's अगर आप 4 और 5 लेते हैं तो 3 on the one side and then 5 on the other side हो जाते हैं so just a blank slide okay so is it visible can you read it
यस सर
all right so we have two data sets of these जो हमने पहले किए थे सैलरीज वाले ठीक है 1 2 3 4 5 6 7 8 9 10 11 12 13 एक में 13 थे और एक में 10 थे ठीक है so for this 13 persons salaries data set इसका तो होगा n plus 1 divided by 2 तो बजाय कि हम एक एक काउंट करें टोटल नंबर हमें पता है it's a 13 plus 1 divided by 2 is the seventh number so this is just the seventh number this is median of this data set 1 जो हमारे पहले एग्जांपल में weekly salaries वाले में ठीक है now the second example has 10 values so out of these 10 values how we can compute the mode so the two middle values will be like mode so it will just start from n by 2 and n plus 2 by 2 so if you will allow me to write it will be like जो आपने पूछा है कि वो compute exactly कैसे करेंगे so this will be the formula so n by 2 and n plus 2 by 2 so these two will be the medians in general now for this data set we have n is equal to 10 so एक हमारा होगा fifth and then next will be sixth fifth because n divided by 2 is a fifth and then 10 divided by 2 is a fifth and then 10 plus 2 12 divided by 2 is a sixth one for this particular data set. So 300 and 402 are the medians. The number of observation is 10, so n plus 1, this is 5.5. Consequently, the median is halfway between 5th and 6th observations. So if just focus on the one median, so that is just okay. So average of these
So,
two, so 5th and 6th,
sir,
and then
sir, I'm just saying कि 350 इसका median है बस.
जी हाँ, I mean average of these two. वो जो locate करना था आपने, वो these two numbers, n by 2 and n by 2 for 5th and 6th, not 4th and 5th. ठीक है. Now remember, this is median of this data set. This is median of this data set. Mean इसका क्या आया था? 487 something. इसका mean आया था 470 something. Yeah. So these two things, I mean, the mean and median, they give different information, not exactly the center of the data. So we call them this mayors of center. All these are supposed to be center, but not literally or exactly they are the center of the data. Okay. So this was example. Okay, third type is like mode. Okay. This is how we compute. I would like to excuse it.
Sir, your mic is off.
Institute of Business Management.
जी exactly. Do we have some messages? He's talking on call. Okay, thank you. Okay, just give me 2 more minutes. I will be back. Yeah. Okay, I'm back. Yeah. Screen is visible, everything is okay. Are you there with me or just left me? Can you hear me, guys?
Yes, sir.
All right. Yeah, otherwise I just feel in a desert. I don't know who am I talking, so it's very difficult. So, okay, so mode, the another type of measure of the central tendency, not exactly central tendency, but it's just a measure of the data, gives some kind of information about data. This is how it is computed. Oh my God. So this is how it is computed. So it's computed like just locating the value that occurs most often. The most frequently occurring value is called the mode. Okay. These are further properties. It's also not affected by the extreme values, be it minimum or maximum. There may be, so this is a drawback, again, apparent drawback, there may not be a mode if the values, all values are like in the same frequency. So there may not be a mode. So let me just give you some example. Okay, ऐसा कैसे हो सकता है कि मोड ही ना हो? So consider this, data. कौन सा data होना चाहिए? Okay, we have this very homogeneous data. Height and number of people. So let's say start with 4.5, 5.0, 5.5, 6.0. We have 1,000 people in this one, 1,000 in this one. Let's go खामोश कैसे किया जाए? Okay, so 1,000 people in this third class and 1,000 in this third. So we have same number of people, same number of frequency in with a different heights. So there is a no, let's say, frequent occurring value in every, for every character or every this, this aptitude property, we have same number. So there is no mode. Mode is जहाँ पर मतलब ज़्यादा number of occurrences हो, frequently वो value occur हो रही हो. ठीक है? So this is data in a, let's say, town 1, and for example we have a data number of people in town 2. वहाँ पर data कुछ इस तरह है.